Welcome back, folks. Got a short lesson for today. 4.3, Limits of Rational Functions. Now, we've done a little bit with limits so far this semester. Okay, remember, they're important because limits are what make calculus work, basically. And rational functions and their graphs are actually a very good kind of function to use to explore limits more and talk about limits. Alright, so jumping straight into problems. Problem 1, describe the asymptote of the rational function using limits. So what I have here is a graph of a rational function. We're not sure what the equation is, but that doesn't matter. We're just going to do this visually here. Okay, now if I have 1, 2, 3 different asymptotes, and these are going to be places where the function is undefined, okay, or places that the function continues to for n behavior, I can't evaluate my function for those values. But what we'll do is we'll describe what's happening using limits. Okay, we're going to start off with finding n behavior with limits. And this is going to be similar to what we did with polynomial functions. Now when I'm talking n behavior, what we're looking at specifically is my horizontal asymptote. Okay, we want to know what happens as my graph continues to the far left, and then also follows that horizontal asymptote to the far right. Okay, so on the far left, just like we did with the last chapter, we'll say the limit as x goes towards negative infinity of f of x. So in other words, as x continues on and on to the far left of this graph, okay, well we see this graph's leveling off at my asymptote at y equals 1. So I'll say that limit is just equal to 1. Again, this is just a fancy way of saying is as x continues to go left, f of x is going to go towards 1. Okay, we can't evaluate f of x at negative infinity, but we can describe what's happening using limits. Same idea for the far right side of the graph. As x continues off to the right, we'd write that as limit as x goes towards positive infinity of f of x. And that's equal to 1 as well. That's the same asymptote. So we'll just say that limit is equal to 1 also. In most cases, as long as you don't have a slant asymptote, rational functions are going to have the same limit for negative infinity and positive infinity. Alright, so there's our n behavior. And next thing we want to do is describe the vertical asymptotes using limits. Again, where an x value hits a vertical asymptote, that's where our function isn't defined. So in the case of x equals 2, I can't say what is f of 2, but I can describe what's happening there using limits. So what we'll do here is we'll say the limit as x goes towards 2 of f of x. Okay, so as x is approaching 2 from the left and right, since my graph's continuing down forever, I'll say that limit's equal to negative infinity. Again, all that's saying is that the closer x gets to 2, the farther down my graph goes. Alright, now last thing we're going to do is describe this function at the asymptote of x equals negative 3. And now this is going to be the one tricky part of this section. Okay, reason for that is if I want to know what my function is doing at x equals negative 3, well that depends on what side of negative 3 we're talking about. If we're coming towards negative 3 from the left, we'd say it's going up. If we're coming at it from the right, it's going down. Okay, for that reason, I can't describe this asymptote with a single limit. I've got to use two separate limits. Okay, if you ask me what's the limit as x goes towards negative 3 of f of x in this case, I'd say it does not exist because it's doing two different things on both sides. So what we'll do is we'll talk about a left-sided limit. That's saying as we go towards the value from the left side. And the way we'll write that out is we'll say the limit as x goes towards negative 3, kind of raised to a negative power. That just means coming from the left of f of x. Okay, as I come to negative 3 from the left, my graph's going up. So I'd say that limit's equal to infinity. And then for the right side, we'll write it as the limit as x goes towards -3 from the plus side of f of x. Okay, so as I approach f of x from the right side, my graph's going down. So here I'd say that limit's equal to -infinity. And that's really the difference between the two types of asymptotes we have here. If my graph has the same behavior, if it's going the same direction on both sides of that asymptote, you can write it with a single limit. If it's going in different directions, that's where you need the left side and the right sided limit, okay, where one's going to be infinity, one will be the -infinity. All right, problem B is the same idea. Why don't you hit pause on the video, see if you can come up with those limits quickly, and then hit play to check your answer.